The answer is choice D. So you're going to take the derivative. So we're going to start by taking the derivative of cosine. So the derivative of cosine, the derivative of sine is cosine. Cosine u. Now we have to take the derivative of that. So that's going to be the first times the derivative of the second plus the second times the derivative of the first, which is just 1, equals, and then the derivative of x is 1. Okay, so now what I want you to see is I really have here, I've got this cosine xy, and I'm going to take that and distribute that through to both terms on the inside of that parentheses. So what that's going to give me is that's going to give me x times the cosine of xy times dy dx plus y times the cosine of xy. And that equals 1. All right, so the goal, remember, whenever we're doing implicit differentiation, and in this case they're asking for dy dx, so we want to find dy dx, so I want to get anything that has the dy dx on one side of the equal sign. So therefore I'm going to take this and I'm going to move it over to the other side. So that's going to give me x times the cosine of xy dy dx. That's going to stay on the left-hand side of the equal sign. And on the right, I'm going to subtract over that y times the cosine of xy. Okay, now I want to get the dy dx by itself. So I'm going to divide by x times the cosine of xy. And then you can see, hopefully at this point, that your answer is choice D. Okay, I'm going to be lazy here. There you go. The answer is choice C. Now, I rewrote this little fact right here. This is the graph of f, but I also want you to see something, and I think we talked about this, but I want to just talk about it again just in case because I'm not sure. So if you look at this, right, we see that g is equal to the integral from 0 to x of f of t dt. Now, the question, though, is talking about g and having a point of inflection, which I know means second derivative of g. So I want to see if there's some relationship between f and g down here. Do you remember I said to you, if we take the derivative of one side and the derivative of another side, remember that fundamental theorem of calculus states that by doing that, this will cancel each other out, right? They're inverses of each other. And because the bottom bound is a constant, we can take this top bound and drop it right in there in place of that t. So then really what this is saying is, instead of writing d dx of g of x, that's really just g prime, right? That g prime of x is equal to, and then remember, these guys cancel out, and that x goes right in that place. So this is really important because I want you to take this fact here and look at what I have here. So that's the graph of f, which means really then it's also the graph of g prime. Okay? So then that being the case, if I want a sign chart for g double prime, and this is the graph for g prime, then I just have to look for increasing, decreasing, don't I? And I see that the function is increasing till I get to 2. It's decreasing after that until I get to 5. And then it's increasing after that. So it's asking for where we have points of inflection. And remember, points of inflection are always going to be where the second derivative changes sign. So it changes sign here about x equals 2. And it changes sign here about x equals 5. And that's why the answer is choice C. The answer is choice A. Now they tell you that you have this line and that it's tangent to this graph right here. So that means they're going to have the same slope. So let me just find the slope for this line. And if I go y equals negative x plus k, do you see then that my slope here is negative 1? So that means the slope of this graph will also be equal to -1. And how do we find slope of that graph? We find that by taking the derivative. So 2x plus 3, and I'm going to set it equal to -1 because, again, they said that this line is tangent to this graph, which means the slope of this graph, aka its derivative, is equal to the slope of this line, which is -1. All right, so I'm going to start by solving. So that's going to be 2x equals -4. So x is equal to -2. Now that's not what they want. They want the value of k, but I'm looking at this right here, and I just found the x value. If I could just find the y value, right, wouldn't I have what k is? So how could I find this y value? Well, if I know the x value, couldn't I plug it back in here and I'll get my y value? So that's what I'm going to do. So basically, you've got y equals x squared plus 3x plus 1, and I'm going to plug in 2. -2, sorry. So -2, when I square that, is 4, plus 3 times -2, which is going to be -6, plus 1. And when you work that all out, that is going to end up being, what, -1. Okay, so there's my y value. So I'm going to take these two values, and I'm going to look back at the line that they gave me, which was x plus y equals k. Well, I know x is -2. I know y is -1. And that would be my k value, which is going to be -3. The answer is choice E. So just be a little careful here, because I would tend to think that maybe most of you would have chosen choice A, and I understand why. Remember, when we do a horizontal asymptote, by definition, it is a limit as x approaches infinity, and that's probably what you did. So you looked at the highest power on the top and the bottom, and you saw that that reduced to -1, which is true, by the way. However, by definition of a horizontal asymptote, and we don't see this as often, you can also have x approaching -infinity, which would be looking at the other end behavior. And if you look at that, that reduces to 5, and that's why the answer is choice E. A little tricky. The answer is choice D. So they gave you a second derivative, and they are talking about points of inflection, so I know that that would be a second derivative sign chart, and I want to see sign changes. Well, I'm going to start by finding the zeros. I know I've got x equals 0 here. I have x equals 3 here. And over here I have x equals 6, right? So I'm going to put those guys on my sign chart, 0, 3, and 6. And then you're just going to plug in numbers. So, for example, you could plug in -1, you could plug in +1, you could plug in 4, you could plug in 7. And I would plug them right in here and see if you get positives or negatives. Okay? So when you do that, I have a positive, then a positive, then a negative, then a positive. So just be a little careful. Oops. Be a little careful here, because we're not having any sign change here. So 0 is not a point of inflection. So the only point of inflection would be 3 and 6, because we have sign changes about those points. The answer is choice A. Now they're basically asking for what values of t will the velocity be increasing. And velocity is going to be increasing when my acceleration is equal to a positive number. So I have a graph here, and this is a graph of the position. And so basically, what I'm going to be looking for is a change in concavity. Okay, because this is the position equation, and if I know that I'm looking for my acceleration to be a positive number, I want to see where I have changes in concavity here. So a change in concavity, let's see. So I'm concave up, concave up, concave up, and at x equals 2, it says it right here that we have a point of inflection. So what that means is at x equals 2, I go from being concave up to concave down, and if you notice the rest of the graph is concave down. So right here at x equals 2 is where I have that point of inflection. So if I were doing a sign chart for the acceleration, 2 would be my point of inflection, and I would be going from concave up to concave down. And it asks, again, let's go back, I'm looking for where the acceleration is a positive number. So any time prior to time 2, and that's why the answer is choice A. Right, the answer is choice B. This is kind of a tricky question. It's a wordy question. All right, so I want to actually focus in, and I know I'm kind of skipping stuff, but I want to focus in on this because we need to know what P stands for. And that's the number of people who have heard the rumor. Okay, so I'm going to go back then from the beginning. It says the rumor spreads among a population, so that would be the number of people, right? Among a population, that population is n people, and it says at a rate. So remember, whenever we have a rate, that signifies derivative. Okay, so then I would tend to think, well, the population is P, right? So dP dt. Now, the next key word, I guess, would be proportional, or words, proportional to. Whenever I see that phrase, proportional to, I think fraction. Okay, so rumor spreads among a population at a rate, that's your dP dt. I see proportional to fraction. All right, now let's see what's going to go in the denominator, because the denominator says product of, so we know that we're going to have two things in the denominator multiplied together. Product of the number of people who heard the rumor, right here, so that's P, and the number of people who didn't hear the rumor. Okay, so we know that there's going to be a P down there, and then we know that there's going to be something else down there, right? And that's the number of people who didn't hear the rumor. Well, if you go back and you read the original first sentence here, it says the population is n people. So that's your total. So if you have n people and a certain number of them heard the rumor, then the way to figure out the number of people that didn't hear the rumor, wouldn't you subtract? So that's what goes in here. And then the other thing that we want to take into account is when we see that word, that phrase proportional to, not only does it mean division, but it also means that we set this equal to a constant. And I do believe we probably talked about this, but it's been a while. Okay, so then look, the rest is a piece of cake. That was the hard part. Cross multiply. So if I cross multiply this way, you'll see that I get dP dt equals, and then when I cross multiply this way, I get K times the P times the N minus P, and there's your answer, choice B. So the answer to this question is choice E. Now, I don't know if you remember, but this was a question on, I think, your last test. All right, well, who cares if you don't remember, no biggie. We're going to cross multiply. So I'm going to get y dy equals x squared dx. Okay, so remember, we're going to integrate both sides, and that's going to give us 1/2 y squared equals 1/3 x cubed plus c. All right, so right here, I got the y by itself. I'm going to plug in the point that they gave me, which is 3, -2, and that's going to help us find our c value, right? So when I plug in -2 on the left-hand side, that's going to be 1/2 of 4 equals 1/3 of, what is that, 27, right? Plus c. So that's going to give me 2 equals 9 plus c. So I know that c is equal to -7. All right, so let me plug that into the equation. So I have 1/2 y squared equals 1/3 x cubed minus 7. Okay, So what I'm going to do first is I think, let me just get this set up. I'm going to just take everything here and I'm going to multiply by 2 because that way I can get rid of that 1/2. Okay? All right, so then when I do that, I'm going to get y squared equals, and that's going to be 2/3 x cubed minus 14, right? And then I'm going to square root. Now this is the part where it gets a little tricky, and some of you got this right on your test, which was awesome. When you square root, remember, you need a plus or a minus. So we're going to get 2/3 x cubed minus 14. Okay, so, and this is where on the test, some of you said it was choice D, and some of you said it was choice E. I gave you credit, by the way, for both because it wasn't something that we really talked about. However, I'm going to talk about it right now because really the only correct answer is choice E. So what you have to do though to make sure, like, well, which answer is it? Is it a positive or is it a negative? Is it both? So what you have to do is you have to plug in that point that they gave you originally, which was 3, -2. It's sort of like a check, okay? So if I put in a -2 here, that's the y value, right? And let's say I'm going to look at the positive square root. Let's see if this works. So 2/3, I'm putting in what? +3, right? And cubing that, which is 27, minus 14. Okay, so let's see. Now really, I don't know if this works, so I'm just going to put a question mark there because I'm really not sure yet, and let's just see what we get. That's positive. Okay, well, what that's going to give me then underneath the square root, let me see, so that's going to give me 9 times 2, which is 18 minus 14. Sorry, so that's -2 equals the positive, and 18 minus 14 is 4, and the square root of that is 2. Well, look at that. That does not work, and that's why the positive square root is not your answer, and it's not choice D. Now, I'm not going to show you this, but if you plug in 3, -2, and instead of having a positive here, put the negative there, you will see that it does work out. So the answer is choice E. The answer is choice B. So tangent line, so I think y minus y1 equals m times x minus x1. And then they did tell us to use x equals 2. So that means I'm going to put in a 2 here. Okay. Well, at x equals 2, I want the y value. So there it is right there. That would be a 1. Okay. And I also want the slope at x equals 2, which would be right there, right, which would be a 4. So there's the equation of my tangent line. Now, what they want, though, is what is the value of the approximation of f of 1.9. So I'm going to be putting in 1.9 for x. So y minus 1 equals 4 times 1.9 minus 2. I'm going to solve this for y. So y equals 4. And this is going to be -0.1 plus 1. Okay. So then that's y equals -0.4 plus 1. So y equals 0.6. And there's your answer. All right, the answer is choice B. They told you that the function is differentiable. So if the function is differentiable, that means it also has to be continuous. So what I would do here is I would plug in 2 into the top part of the piecewise function, which will give me 2c plus d. And then I'm going to plug in 2 into the bottom part of the piecewise function, which will give me 4 minus 2c. Okay, so I'm going to write this down. I know if a function is continuous, that those two values then have to be equal to each other, right? Okay, so I'm going to move that 2c over, so that's going to give me 4c. And I'm going to move the d over, and that's going to give me 4 minus d, right? 4 minus d. Now, that doesn't help me all that much, right? Actually, you know what I'm going to do? I'll leave that for now. How about that? We'll leave it. So I'll come back to that. But it's also going to be differentiable. So I am going to take the derivative then of the function. And when I do that, I'm going to get c in the top and 2x minus c in the bottom. And I'm also going to plug in 2. Well, if I plug in 2 here, don't I still end up with c? And if I plug in 2 here, I'm going to end up with 4 minus c. And if it's differentiable, these two things here should be equal to each other. So c equals 4 minus c. So that gives me 2c equals 4, and c is equal to 2. So now I can take this value and plug it right back in there. And now I'll be able to solve for my d. So that's 4 times 2 equals 4 minus d. So that would be 8 equals 4 minus d. So then d will equal -4. Okay, now that's not what they asked for, but we got it. So what they asked for was c plus d. And that's easy enough. So that's 2 plus -4, which is -2. Okay, so this question is asking for the slope of the line tangent to this curve. So what I did was, you remember we talked about this formula here, okay? And the formula was 1 over a. Now this says arctan. Remember we also had tan to the -1. It's the same thing. What I want to focus on is the fact that here and here, I don't have a number up here. So do you agree that I can assume that my a here is going to be a 1? Okay? All right, so they're looking for the derivative. And if you remember, the derivative is du over a squared plus u squared. Okay, now let's talk about the u. This is going to be my u. So my u is 4x, right? So that means my du will be 4. My a, we already know is 1, so that's just going to be 1 squared, which is 1, plus u squared, right? So here's my u squared, and this is my u. So if I square that, that ends up giving me 16x squared. Okay, so there's my derivative. So let me just go through this again. Du, well, if my u is 4x, then du will be the derivative of that, and that's where that 4 came from. A squared, here's my a. Square that, I get 1. U squared, here's my u, square that, and I get this. Okay, now, what they want, though, is they want you to take that, and they want you to evaluate this at x equals 1/4. So I'm going to plug in 1/4, and then I'm done. So 4 over 1 plus 16 times 1/4 that quantity squared. Okay, I'm going to just continue it down here. So I've got 4, 1 plus 16 times 1 over 16, which equals 4 over 2, which is 2. And the answer is choice A. Okay, the answer is choice C. Now, I can eliminate choice E because none of these slopes horizontally or vertically are the same. So that being the case, it's not going to be dependent on just one variable. So you're going to have both an x and a y in there. So what I started doing was I looked and I saw that at 1, 0, I have a 0 slope. So I plugged in 1, 0 here. And when I plugged in 1, 0 into choice A, I got 0. So that works. I plugged in 1, 0 into choice B. I got 0. So that works. I plugged in 1, 0 here. I also got 0. So that works. But when I plugged in 1, 0 into here, I got 1. So I could eliminate that. Okay, so then I was down to these three guys. So then I tried to pick a different point. So I looked at the point -1, 1 here. Again, 0 slope. So -1, 1 is the point that I plugged in. So when I plug in, and I'm going to write that point, negative 1, 1, that's the point that I plugged in to my derivative here. That's negative 1 times 1, okay? And negative 1 times 1 is negative 1. Well, the slope is 0, so that's not it. So now I'm going to plug in negative 1, 1 here, okay? And when I do that, if I put negative 1 times 1 here, that's negative 1, minus 1, which is negative 2, right? So that's not it. However, when you plug in to choice C, if you plug in that negative 1, 1, okay, you're going to see that you're going to get negative 1 plus 1, which is 0. So that's your answer. Okay, the answer is choice A. Now, they're asking you to find G prime of 3, and they're telling you that G and F are inverses. This is what we just did before school let out. So if I want G prime of 3, let's look at the fact that right here for F, I know the point that we're gonna kind of focus on. F has the coordinates 6, 3. So that means G, which is its inverse, would have the point 3, 6, right? So then if I'm looking for G prime of 3, then the formula is 1 over F prime of 6. Okay, because they're using the X value that corresponds with G. So when we're doing F prime, we have to use the X value that corresponds with F, which would be 6. So we're just looking for F prime of 6, and actually, here it is right here, F prime of 6. So if you understand the concept of the formula itself, this is actually pretty easy. So that's 1 over negative 2, and there's your answer. The answer is choice B. Now you have a graph of the derivative, and they want to know when the function is increasing. Well, a function's increasing when the derivative is positive. So if you have a derivative picture and you want a derivative sign chart, you look for above and below. So that picture is above the x-axis the entire time until we get to 3, and then after that it goes below the x-axis. So this is where the graph is positive, above the x-axis, negative, below the x-axis. So then the question is asking on what intervals is the function increasing? That would be where the derivative is positive, which should be right in here. Okay, the answer is choice C. So if we look at this, the Roman numeral 1 says the limit exists as x approaches 2 from the negative direction. Well, here's 2 from the negative direction. Yes, it does. Again, remember, a limit does not have to exist at that exact point, but coming from the left, it does approach a specific y value. Roman numeral 2, as we approach 2 from a positive direction, the limit also does exist, because if we come from the positive direction, we go towards x equals 2, we are approaching a specific y value. Okay, now let's look at Roman numeral 3. It says that the limit of the function as x approaches 2. When we don't have a little plus or a minus after that number 2, remember that we have to take into account the limit from the left and the limit from the right. So coming from the left, we approach a higher y value than the y value coming from the right. So the limit from the left is not the same as the limit from the right. So therefore, this limit does not exist. And it says which of the following statements are true. So it would just be 1 and 2, choice C.